This video is going to discuss one technique for solving quadratic equations. This technique is going to involve the skill you have called factoring. Before we look at solving quadratic equations, let's look at example 1, which is going to discuss solving a regular equation. So I have 3x minus 2 equals 10. This should be old news for you. I add 2 to both sides, so I have 3x equals 12. Divide both sides by 3, and I'm left with, those all canceled out, x equals 4. Nothing too new there. I could also recheck my answer by plugging it back in. So I could do 3 times 4 minus 2 equals 10. So let's check. Well, 3 times 4, that's 12 minus 2 equals 10. And yes, 12 minus 2, 10 equals 10. So we did it right. Now that we have an idea of what we're trying to do, which is isolate x, let's look at a second example that uses a quadratic equation. Example 2. Now instead of 3x minus 2 equals 10, I have 3x squared minus 2 equals 10. So let's approach this the same way. I'll start by adding 2 to both sides. And now I have 3x squared equals 12. So continuing in the same way as before, I'll divide both sides by 3. So that cancels out. And now I have x squared equals 4. Are we done? No. We still don't know what x is. We only know that x squared equals 4. We still need to do something to find out what x itself equals. Now, many of you may be sitting there thinking, okay, well, if x squared is 4, I happen to know that 2 times 2 is 4, so x must be 2. But let's formalize that a little bit more. When I get to the point that it's x squared equals 4, I know I take the square root of both sides. So I get the solution x equals 2, because the square root of 4 is 2. Again, though, I'm still not done. If you think about this problem, there's actually another number than when I square it, I get 4. And that number is negative 2. The reason is that negative 2 times negative 2 is a positive 4. So it's going to be really important that every time you take a square root, you remember to put both the positive answer and the negative answer, because they are both solutions to the equation. And now, just like before, I could check my work. I could do 3 times 2 squared minus 2 equals 10. Well, 2 squared is 4, so 3 times 4 minus 2 equals 10. 3 times 4 is 12, minus 2 equals 10, and just like before, 10 equals 10. So we did it right. I could do the same thing with negative 2, and again you will see that 10 equals 10. Okay, well that didn't seem too hard. So why do we have a whole video just discussing how to solve quadratic equations? And that's because when we have a quadratic equation, there's the possibility of having not only an x squared, but also an x. This is sometimes called the linear term, because it's the term that has the x with an exponent of just 1. These problems are much more challenging to solve. Let's try to solve it the same way that we had solved the other problems. So I'll start by adding 2x to both sides of the equation, getting rid of it here. So now I have 3x squared equals 10 plus 2x. Well, this is the first time I get stuck, because I can't combine 10 and 2x. They're not like terms. Okay, well maybe I can plow forward. Maybe I can divide both sides by 3 and still see if I get somewhere. So now I have x squared equals 10 plus 2x over 3. Still looking like some trouble. The real problem is that we have no way to get this x and x squared combined. So we have no way to isolate x. So x cannot be isolated. And this is really a huge problem. So, it's a problem. Is there a solution? In fact, there is, and it's called the ZPP. The ZPP stands for the zero product property. And the name sounds much fancier than it actually is. It's actually a very basic idea. The idea is that if I have two numbers, any two numbers, let's call them A and B, and I multiply them, and I get 0, one of them must be 0. This is pretty easy to think about. If I multiply any number that's not 0, I'm probably not going to get 0. 1 times 2, well, that definitely doesn't equal 0. Let's try a fraction. 1/2 times 2, nope, still not 0. -2 times 2, oh, definitely not 0. You could try any other numbers, and you will never get 0. The only way would it be if I had 0 times 2. That's 0. Or 2 times 0. Oh, that's also 0. So the important takeaway is that if I have two numbers multiplied together and they equal 0, then either A or B or both are 0. This is what's going to allow us to solve quadratic equations. The next thing to consider is how are we going to use this? When is this actually going to help us solve quadratic equations? So, for example, if I had a quadratic equation, x squared plus 3x plus 2 equals 0, if I was able to actually factor that, or unfoil it, back to the product of two binomials, I now have a situation where I could apply the zero product property. If I said x plus 2 is A, or an x plus 1 is B, based on the zero product property, since x plus 2 times x plus 1 equals 0, either x plus 2 equals 0, or x plus 1 equals 0. And now we have two very simple linear equations that we can solve. So the first one's going to give us that x equals -2, and the second one's going to give us that x equals -1. Notice we have two solutions, just like we did in that first very simple quadratic equation. Most of the time, you're going to be looking for two distinct solutions. Now let's address when we use this. Well, we can use this whenever we have a factorable quadratic expression and when that expression is set equal to 0. This is the most important part. If your expression does not equal 0, the zero product property does not apply. There's no such thing as the one product property or the four product property or anything other than 0. So the first thing you should always do is make sure you are set equal to 0. Let's see another example of this in action. Here I have example 4. 2x squared plus 11x equals -15. At first glance, this is really difficult to solve because I have two terms with x in it and I cannot combine them. So what I'm going to do is that first step where I'm going to set it equal to 0. In order to do that, I have to add 15 to both sides of the equation. So on the left, I now have 2x squared plus 11x plus 15. That 15 cannot combine with the 11x because it does not have an x with it. And this whole thing is going to equal, well, -15 plus 15 is just 0. So now we have met that condition that my quadratic expression must be set equal to 0. The next thing to do is factor the left side of this equation. So I'm going to use the same method we learned in class to factor this. So 2 times 15 is going to be 30. And now I need to think of two factors of 30 that add up to 11. Well, let's try 1. How about 1 and 30? That's definitely not going to work. How about 5 and 6? That's perfect. 5 plus 6 equals 11. So we found a winner. So now I go back and I split my b term. So I'm left with 2x squared, because that one stays the same, plus 5x plus 6x plus 15. And remember, keep in mind this whole thing still equals 0. That 0 didn't go away. All right, now I place my parentheses around the first two and then the last two, and I go and factor out the GCF. So in 2x squared and 5x, I can pull out an x, and I'll be left with 2x plus 5. And then from 6x and 15, I can take out a 3, and I'm left with x plus 5. Oops, 2x plus 5. And remember, that still all equals 0. And now I'm in luck. I have 2x plus 5 and 2x plus 5, so I know I've done it right. So I've got one set of parentheses with the 2x plus 5, and then my other set of parentheses is the x plus 3. And that still equals 0. Every single step, it still equals 0. I'm just rewriting the left in a different form. Now it's time to apply the zero product property. Since I have two factors that multiply to 0, one or the other must be 0. So I could say that 2x plus 5 equals 0, or x plus 3 equals 0. And now I have, again, two simple equations to solve for x. So I'll start on the left, minus 5, 2x equals negative 5. So x is going to equal negative 5 halves is one solution. And the other one's even simpler, just minus 3 from both sides. X equals negative 3. Now, if you're a bit unclear on all of the factoring steps, you may want to review one of the other videos that I made. But if you followed me from this line down, that means you've understood this idea. You may just need to review factoring. I'm going to do one more example using just the zero product property. So here I've taken out all of the need to factor. As you can see, my example, x plus 3 times 14x minus 90 equals 0 is already factored. It's already the product of two binomials. So all I need to do now is use the zero product property and say that, well, that means that either x plus 3 equals 0 or 14x minus 90 equals 0. This one, again, fairly simple. I'm going to subtract 3 from both sides. X equals negative 3. It's one solution. Here I've got two steps, plus 90 on both sides. 14x equals 90. Divide both sides by 14. X equals 90 14ths, which I believe I can reduce to 45/7. All right, so again, just to recap, two solutions. And in this example, I removed all of the need to factor. Again, if factoring is the problem, please review my previous video. All right, so for homework, I'd like you to try 3 equations. Notice the first one's already factored, so you don't have to factor it. Number 2 and number 3, though, you will need to factor and then use the zero product property. Good luck, guys. No excuses.